Yeah, I think I said at the start of year there are two topics in mechanics that people find difficult. The first topic is projectiles, which we did, and the second topic is this, turning force. And I understand maybe why, but then sometimes I don't understand, because I don't think it's too difficult.
Mechanics would be like harder in university.
It would be too. Okay, let's do the beam.
A beam of steel is 2 meters long and laying on the ground horizontally. The beam has a mass of 60 kilograms.
Okay, sorry, it's 2 meters long, you said. Okay, so
60 kilograms.
this is 2 meters and it's 60. So this is 60 G. Yeah.
A man lifts the beam from one end.
Okay, so what he does is he lifts it here with a force F.
Yes.
And I want to know what is this force.
Yep.
Okay. It's not 60 G. It's not. It doesn't need to be that much. So this is making it turn clockwise, and this one's making it turn anti-clockwise. So this needs to be bigger or equal to this one. So this one here for clockwise, that is 60 G multiplied
By 9.
1
Yeah.
from here to here. And then for the anti-clockwise from the man, that would be F multiplied by 2.
Okay, why it's 2 and 1?
The 1 is from here to here, and the 2 is from here to here. Yeah? So the clockwise must equal the anti-clockwise. So 60 G must equal 2F. So F must equal 30 G. I feel like nobody got this.
No.
Oh man. Alright. F is 294.3 Newton meters. Did everyone say the answer is 60 G?
No,
Alright. What did you say?
my answer is 1177.
How'd you get that?
First
1177?
I find 60 G.
Yeah.
Multiplied by 2.
Yeah.
Yeah, same.
No, I did 60 G multiplied by 1. So I did the first part, but I didn't compare two equations or anything.
But do you understand what happened here?
If we divide 1177 by 2. Yeah.
1177.
Yeah, because it's 2F. That's the missing part.
Yeah. You don't look happy, Fong.
Yeah, I don't know why 2F.
Why 2F? Because
This
you,
is 2 meters.
this is the turn-in point. So it's F multiplied by 2 for the turn-in force. No? Let's see. Remember last time we said if this is D and this is F, then the turn-in force is D multiply F. Same idea. This is D and this is F. So together that's 2F because it's 2 and F. Yeah? I don't think anybody got this.
This turns with force?
Distance by force?
This is not the hardest.
No, it's not the hardest one, which is a problem.
Exactly.
So you can see, the man didn't need as much force as you thought. He didn't need 60 G of force, he only needed 30 G. And the reason for this is what?
Half of it is on the floor. That was it.
What's the reason?
Because he's pushing on one end, so that's half of it.
At what? At one.
The reason is, he is further away from the turning point. So in fact, if the beam was longer, would he need more or less force? Less. So this should remind you of my picture I gave you, where you had the earth and the beam. And the point is, if it's long enough, it's easier to do. So if this is really big, then
forces.
The force can be small to lift it. Yeah. Okay. Right. Any other questions about that?
A second man, B, comes to help. He holds the beam 30 centimeters from one end, and the first man, man A, holds the beam 40 centimeters from
Okay,
the other.
so 30 and 40. Let's draw that then. Okay, so... Well, I hope maybe you got this one. This is part B.
It's two equations, I think.
Yeah, it is, yeah. So, the first man, you said, is 0.3 meters, and the second man is 0.4 meters. So, let's put the middle here. What would this be? 0.7, and this would be 0.6, because the middle is still at 1.
Okay, why it's 0.7 and 0.
Because I want to make a total of 1 meter here, and 1 meter here, because it's 2 meters. And what did we say the weight of the beam was?
60.
60 G. And I'm sure my question is, what is his force and what is his force?
What supporting forces are?
Yeah, so you're right, it's two equations. So what's the first equation we can make? T plus S equals 60 G. 60 times 10^1. So that is T plus S equals 588.6. Okay, that's the first equation. And now the second equation, where should we make the turning point? We can put it anywhere.
Yeah.
I think the easiest and the best place is like here. Yeah. So we got, is this clockwise or anti-clockwise?
It's anti-clockwise.
Clockwise. Going with the clock.
It's going up.
No.
This is, it's going opposite side.
No. Look here. If I draw this, is that clockwise or anti-clockwise?
It's
Clock.
Clockwise.
Clockwise.
Look like the clock.
Yeah.
Yeah. So this is clock, and this one here is
Clock.
anti.
Yeah.
So this one equals this one.
Okay.
Yeah. So what is the distance? 0.7 times 60 G. That should equal.
0.4 or
If we're using the distance from here to here.
0.6.
1.3.
1.3.
Yeah. Times S. So this one is the clockwise, and this one is the anti-clockwise. This one is the up, and this one here is the down. So this is a down force, and this is an up force. This is a clockwise, and this is an anti-clockwise. So this is our second equation. What?
Anti-clockwise.
His name is Andy.
I don't think Andy.
It's anti.
I don't think. Yeah, is that the best you can do?
That's a reach.
It is a bit of a stretch. Anyways, 5 out of 10 for trying. Yeah. Right. So here we get S equals. If I calculate this, I get S equals 316.9 newtons. I believe, yeah? Did you get this?
1.3.
Guys, I was hoping you'd get this one because it's just like my example I did.
So 1.3.
Did you get this? No. Hey, what happened? What did you get?
I only wrote the equation.
Why didn't you solve them?
No, because how you
Can you
got
look?
this number, this 316.9.
This multiply this, divided by 1.3.
Oh. Okay, this is right.
The last three lines.
That's equal.
You're making this so much more difficult than you need to. You know what I mean? Like, I had it done in like a couple of lines, you know? Anyways, look,
I took off.
how can I get the T?
By putting the value of S in the T.
Put it back in here, yeah. So I get T equals 271.7 newtons.
Oh, so I got it 32.3.
For what?
This the S Newton. The
No,
316.9. I got that 32.3.
No. What you got? 32 point.
3.
You forgot to multiply by 9.81.
Oh. So multiply 0.7 with 60.
With 9.81.
Yeah. Also.
Mm-hmm.
Okay.
Part C.
The two men hang the beam on two ropes. Each rope is 20 meters from the end of the beam. What
20
is the tension?
centimeters.
Yes,
Yeah. You said meters.
20 centimeters.
Yeah.
sorry.
Okay, hang on. So, it's on two ropes, you said, and each rope is 20,
20 centimeters.
0.2, 0.2, and then here, 60G. What's this? 0.2 meters, 0.2 meters. What's this distance? 0.8 meters. And here? 0.8 meters.
What is the tension force involved?
So how do I do this one? Is it the same as the last one? No, it's easier. Why am I saying it's easier?
So same distances?
It's all the same. It's all symmetric. So it means that this must be the same as this.
Oh.
So now it's a much simpler 2t equals 60g. So t equals 30g.
So it will be divided 60 with 2.
Yeah, so 294.3 newtons is the answer.
Oh, it's the same as
Ah.
in the same question. Same as B.
The same answer?
Yeah.
That's just a coincidence.
Yeah.
Yeah, just a coincidence. Oh, because you're doing the same thing, you're dividing 60 by 2, yeah.
It's not 294.
Okay, how is
71?
294?
Was it? Oh, it doesn't matter.
No.
How is
You got
294?
That's
That's
60
divided
is,
with
30
Yeah, I got this one.
and multiplied by
Yeah.
9.81, good.
Okay, 60 with 9.81?
Yeah.
Divide 2?
Yeah,
Okay.
congrats. Right, so since you got that one, we'll move on
Yes.
down to D.
Yeah, why am I writing?
Yeah, exactly. Yeah, okay. So what's happening in D?
Man A puts his 5 kilogram tool 70 centimeters away.
Wait, hang on. So I need to draw this again. So the man comes along and he puts some tools on the beam. So it's still hanging.
20 centimeters.
So this is 0.2 meters, 0.8 meters, 0.8 meters, 0.2 meters, and here is going down with 60 G. And where does he put his tools?
10 centimeters from one end.
So like here.
Yeah.
So that's 0.1 meters and 0.1 meters here and here.
Man
Yeah.
B puts his lunch
Oh, japers. Right, go
1
on.
kilogram.
Oh, sorry, what was this mass? Do we know this mass?
Yeah, 5.
5 kg, was it?
Yeah.
Okay, and then he does the same?
No, 1 kg, 10 centimeters.
Okay, sorry, 1 kg. Yeah, and then the other man?
Like 2 men put each 1 5 kg, 10 centimeters, 1 kg, 10 centimeters.
So which is this one, 1 or 5?
It's the same.
It's the same distance. So
Oh, it's the same distance. Okay, so it doesn't matter then, right? So we'll say the 1 is here, and we'll put the 5 kg here, and this is 0.1 meters, and this is 0.1 meters. Yeah? And is the question going to be, what is the tension in the ropes? Now, will the tensions be the same here? No, because it's not balanced, it's not symmetric. So this will be a T, and this will be an S. Okay, so let's, I didn't put in the lunch, so that's 1G, and here, 5G. Okay, so T plus S equals
The total of
60G plus
5G plus
5G plus
1G.
1G, so total is 66G.
How? How is
60G, 5G, and 1G.
647, I think.
And you have it as newtons? 647, you're right. 647.5 newtons. Okay, that's the first equation.
So, 60 plus...
Plus 1G plus 5G.
Okay.
Yeah. Now, where will we put the second turning the turning point? Well, let's do the same thing. Let's just put it right here.
Uh-huh.
Okay, so firstly, is this clockwise or anti-clockwise?
Clockwise.
Anti, because it's making it turn around this way.
I don't understand this thing, the clockwise.
Yeah, it's a
I
bit-
know that, they work, but
This is the
How
turning
can
point.
we-
This is the turning point, okay? So if I have a force like this, imagine you continue the force, if you have a clock hand here, a clock hand, this is a hand of a clock, will this force make it turn anti, or will it make it turn with the clock?
you know, it will go.
It'll go anti. So what you do is you imagine there's a hand from here to the force, like a clock hand. And will this force make it turn anti-clockwise, or will it make it turn with the clock,
No,
clockwise? Anti-clockwise.
Okay.
Yeah? Let's try the next one. So this one anti or clockwise? So this one anti, this one
Clock,
clockwise, yeah? This one
clock.
anti, I think. This one.
Clockwise.
Now again, if we put the hand here, it's making it turn.
Oh, from the turning point. Okay.
Yeah, from the turning point, yeah. So this one's anti, and this one
Clockwise.
clockwise.
Oh, yeah.
You can picture it. You have to
Yeah.
picture it.
Mm.
Yeah, is that okay?
Think about it.
Yes, it requires some thinking, yeah. Go on. You don't look happy. It's this one, is it?
Yeah.
Yeah, okay. So look, I draw a hand here to here. Will this go up or will it go down? It will go up because of this. So if it goes up, it will go around like this. Is this clockwise or anti-clockwise? Anti-clockwise, yeah? Okay. Right, so we have 2 clockwise and 2 anti-clockwise. Let's do the anti-clockwise first. So what's the distance here? From here to here, what's the distance? 0.1. And the force? 1G. Plus, and what's the distance here? 1.6. And the force is F.
Oh.
Yeah. Okay. Equals, right, what's this distance? 0.8, and the force? 60G. And then from here to down here?
1.8.
0.8, 0.8, and 0.1. So what's that? 1.7. Yeah. So plus 1.7, and the force? The force for the last one? 5G.
5G.
Is 60 or 16 this one?
This one is 60.
Okay.
Why number 1 is anti-clockwise?
This one?
Yeah.
Because if this is the turning point, this is making it go backwards around the clock. Because it's pointing down.
How?
This is pointing down, isn't it?
Yeah.
So it makes it go down. So this way
Okay.
is anti. Yeah. Right. So just to be clear, this is the up force, and this one here, the down force. This one here, clockwise or anti-clockwise? What did we do first? we did anti-clockwise first, wasn't it? So that goes this way, and then this one is clockwise, so it turns that way. So these are equal, and these are equal. Okay. Why is this one good? Because,
It's not moving.
Linear.
no, the equation, why is it good?
Because it's
Linear, we got the.
Yeah, I can easily give you the S, can't it? Easily. So let me get the S for you from this. Let me see.
345.8.
You sure? 345.8.
okay. 0.8.
Excellent. And then the T,
301.5.
301.7.
We multiply the numbers.
I solved this one for S. Solve for S. And then once I got the S,
Yes.
I put it in here, and this gives T. Once you know the S, you can easily get the T. This is like what you do in math class, the degree 2 system. You have elimination, substitution, all the different methods to solve it.
Yes. But this I want to get the S.
Yeah, you solve it from this equation. So
Okay. So
take this
yes.
to the right,
Okay.
calculate on your calculator,
Yes.
and then
divide
divide by 1.6. Yeah, yeah.
Like do this and then divide it by
1.6. You got it.
Okay.
Yeah.
Okay. 1.1 times 1 G.
Yep.
From where we get this?
This one,
Yeah.
that is from this one. The distance is 0.1, and the force is 1G.
And the second one?
And the same idea, the distance from here to here is 1.6, and the force is S. Then this one is from here to here, and the last one is here to the lunchbox.
Okay, can I see? Can you?
I'll go down, yep.
No, still I didn't get.
Okay, you must be typing something in wrong. We can have a look at it later. Did you type in this plus this minus this?
No, this
Plus this minus this. Yeah. Okay, can we go to the next part? What's happening in the next one? Did you write this down? Yep.
E, right?
Yeah, what's happening in E?
Finally, man A slides his tool along the beam.
Until the forces are equal, is it?
Yeah.
Yes. Okay. So I'll scroll down. So, in the last part, we still have T, and I tell you in the question the forces are equal in the tension, didn't I?
T.
So T as well. Which man slides his lunch? The 1 or the 5? The 5 kg man.
A, yes, 5 kg.
So he slides his lunch along. We'll just draw it here. I don't know. That's 5. The other one is still. Wait, I thought that was 1 on the left.
Yeah.
Yeah, sorry. So I want to keep it the same. Sorry. So the 1 stays here, and the other man moves to 5. I don't know where it is. I'll just write 5, and we'll call this distance here X. We don't know where it is now. He moves it, okay? But we still know the weight is 60 G. This distance, 0.1 meter. This distance, 0.1 meter. This distance, 0.8 meters. This distance, 0.8 meters. This is X, and we don't actually know this distance here, but I don't think it's too important. We should also work out the distance from here to here, because we're going to take this as the turning point again. So that's 0.8,
Minus.
0.8, but this is a bit weird. This is an x, isn't it? So what do we do?
1.6 minus x.
Oh, you're close. But in total it's 0.8 and 0.8 and 0.2. This here is 0.2, isn't it?
Oh.
So that's 1.8 from here to here. So this should be 1.8 minus x then. Here to here is how much? 1.8.
Yeah.
Here to here is x, so then the remaining piece is 1.8 minus x. Okay. Right, so the force going up, that's 2t, and the force going down, what's the force going down, how much?
The total.
Yeah, which is how much?
66.
66g. So T equals 33g, which is 3 to 3.7 newtons. Now that's not what I want. I want the x, isn't it?
At what point during the sliding of the tools are the
Yeah, so we need to find the x. So we'll make the turning force equation. Right, so let's get this perfect. Clockwise or anti-clockwise? This first one here.
Empty.
Very good, anti. Don't care. This one,
Clock.
clockwise. This one,
And
anti. This one, clockwise. Okay, so let's, what will we do first? Clockwise? We'll do clockwise. So what is the distance here? The first clockwise, what's the distance? 0.8. And the force? 60g. Okay. The next clockwise, what is it? To the next one? How much is it? 1.8, 0.8 and 0.1. So what's that?
1.7.
1.7 and the force? 5g. Okay, now the anti. What's the
How
distance?
did you know it's 1.7?
0.8, 0.8 and 0.1 makes 1.7 if you add them. Okay, what was I saying? Anti. So what's this distance?
0.1.
Yeah, and the force?
1g.
1g. Okay, now the next one, the distance
1.8 minus.
plus 1.8 minus x, and force for his lunchbox?
5g.
5g. So in fact, I didn't even need to know this. It's not necessary to know.
Yeah.
We can solve this for x. So let me see. 0.8 times 60 times 9.81 plus 1.7 times 5 times 9.81. So on the left, I'll get 554.3. And then on the right, I'll get 0.981 plus 1.8 minus x times 5g, which is 49.05. Okay, so now I should multiply out. Um, 88.29 minus 49.05x. I just multiplied it in.
Yeah.
What type of equation is this? Linear, which is no problem to you, I'm sure. Uh-oh. I've got a negative answer for x.
About 9.48.
For x?
Yeah.
Really?
Minus 9.48.
Ah, rats, I made the same mistake. There's a negative answer.
Yes, for me it's the same, negative answer.
Rats.
So it must be positive.
I know an easy way to fix it. In the question, did I say the 5 kilogram man moves it or the 1 kilogram man moves it?
The 5.
I specifically said the 5.
Yes.
Say man A.
Man A And in the first question, man A puts
Was
his
five,
5
yeah.
kilograms.
Yeah.
Not again.
Let me try.
My x is negative again.
We can't make the beam longer.
Like last time.
No, we can't make the beam longer like last
Oh.
time.
I got the 40 point.
Okay, I'll just, so the x will be less than 0 again. So that means the lunchbox will be over here.
Mine.
Yeah, man.
Yeah?
Sorry?
If the x is negative, the lunchbox will be over here,
I'll slide it like.
off the beam, yeah. So,
We can make the beam longer.
It'll change them.
yeah, I'll just change the question to make this fine. So we'll just rechange the question to prove the tension will not be equal. So the answer is, it's not possible, because the only way to make these equal is if the lunchbox is off the beam. Okay, so we'll just change the question to make our answer work. So the question now says, prove the tension will not be equal. That's the question.
No, you can say like, how far can we extend the beam? And we'll have to...
Oh, okay, right. Okay, we could say, how far should we extend the beam so it's equal? Yeah, you could do it that way as well if you want. Yeah. The man puts a stick at the end of the beam. How long is the stick required to be? Yeah.
But if it was like this, from where should we add the distance we get from the end?
Yeah, it would be, yeah, it'd be from the end. So what did you get, 9.8 was it?
Yeah, 9.4.
Yeah, so this needs to be like 9.4 meters out. Extra, yeah. Seems too long.
Yeah. No, we can extend it that way.
No, not with a stick.
Why is it?
If you solve this, the answer will be negative if you solve it.
No. That why we got X? Because go on.
Go up, yeah? Oh, why is it like this?
Why there is X? Because the is 2 and the one is 1. So the another one is 1 also.
This x here?
Yeah.
Ah, but in the last question I didn't tell you where this is. I said he moved it. I didn't tell you where he moved it to.
But you say here it's 0.1 G. So the another.
Yeah, this one. This stays where it is.
Okay.
Yeah. The beam is not long enough. Yeah, this is the reason. Okay. Maybe I'll just delete that question. I had the same trouble last year and I forgot to fix it. So I think I'll just delete it. It'll be easier. Okay, we'll close this one and then start the next lesson then. Yeah. In the exam, see, what happens is I get these great ideas for questions and then they don't really work sometimes. In the exam, this is too difficult for the exam. The exam questions are more like this one. T plus S. This is what you get in the exam. No, just like this one. This would be like a section A question in the exam. Part B, T plus S. Yeah? Okay.